Okay, can we start?
Yes, I was about to say, uh,
Yeah.
as more than 50 participants have already joined. Good morning, all of you. Uh, okay,
Good morning once again, Drupti.
and I welcome you all to this ninth session of this 5 days online FDP sponsored by Hotel Academy, AICTE. So for this session, we have Bikram again with us. So let us welcome him for this particular session. And he has provided few data files, and I have shared it in the WhatsApp group. So you please keep it with you ready, so that we can conduct this particular hands-on session smoothly. So Bikram, welcome to this session, and it is up to you now. I request you to start the session.
Yeah, sure. Thank you. Thank you very much, Drupti. Good morning, all. So let
Good morning,
me.
sir.
Good morning. Let me start sharing it. Trupti, I can stop the
Yes,
video,
yes,
right?
yes, yes, yes.
Okay. Okay. Hope you all can see my screen.
Yes, it is perfect.
Okay. All right. So, first of all, good morning, all of you. Hope last session was very fruitful for all of you. Before I start, I would like to hear any specific question or queries you all have. Can you please let me know? Okay. Okay, all right. So without delaying further, I would like to start for today's session. The today's session will be primarily covered on the unsupervised model and the learnings. As you all are aware, last week I did share about the primary difference between supervised and unsupervised model. So here we don't have any defined output as such, right? Unlike in supervised model where the input data was having x and y variable, but in unsupervised model, we would be trying to see the data that does not have any output variable. For example, let me share here my screen. So you all can see my data. This is a small example. Can you all see my Excel spreadsheet?
Yes, sir. Yes, sir.
Okay, okay. So here it contains, say, for example, a list of customer IDs, their names. I just make it very simple. And what is their average monthly spend, how many times they are visiting to the bank, how much how many apparels they are trying to purchase, what is their uh, profit and loss items, or any other special items that they wanted to buy, how many staple items they are buying it. So as you can see in this particular example, right, we do not have any output or y variable as such. This is all we have, a kind of a only x set of x variables that we would try to apply any unsupervised model on top of it. Okay, so the primary purpose of using unsupervised model is to apply your machine learning techniques on a set of data that does not have any uh, output variable as such. So what we generally do in unsupervised model, I would say, before we go in more detail into what are the types of unsupervised models and what are the various features or various performance measures of the unsupervised model, I would like to speak on the prerequisites or the fundamentals before we learn unsupervised models. What are the things that we should be aware or we should be knowing about? So the first of all is unsupervised learning class. It is nothing but a machine learning technique to derive the pattern of the data, right? So here in my in the example that I was showing it, what would be the pattern of the customer of purchasing? What is their purchasing pattern? What is their number of visits pattern? What is the apparel items purchasing pattern? All those patterns we would like to derived. So that is the fundamental principle of any unsupervised model that we would be learning about today. So, so, so whenever we try to find a pattern of certain data, right? How would we like to derive or define the pattern, right? The pattern is nothing but you are trying to group the whole set of input data into various categories. For example, there might be high spending customers, there might be medium spending customers, there might be low spending customers. There might be customers who used to visit the shops or retail banks or whatever on quite number of times, or there might be some of the customers who don't like to visit to the bank or retail shop. So you're trying to group those patterns into various clusters, right? So the one of the basic method or concept for grouping any pattern of the data is to measure the distance between the two records or two features. For example, how far this customer A is away from the customer B. If you see that if the distance between these two customers in terms of all these features what we have, if it is near about, then we will try to group these two customers, right? Similarly, if we think that these two customers are having a similar pattern, then we will try to group them to a one set of group. So that principle or that method of grouping the various customers would be identified by calculating the distance between two records. Now, so there are four types. Primarily, there are four types of distances that we should be knowing about in machine learning techniques. That, I mean, there are so many other distances, types of distances, but predominantly these are the four types of distance that they use in machine learning techniques. One is the Euclidean distance, Manhattan distance, Chebyshev distance, and Minkowski distance, right? So the equivalent Euclidean distance is nothing but if you're, so I'm taking here a data set of two variables, x and y. Now you will have a x value here, and you will have a x1 y1, and you will have a x2 y2. So what we wanted to define the distance between these two is nothing but, you all might be aware of, it is x1 square x1 minus x2 square plus y1 minus y2 square of distance. So this is what the we call as the equivalent distance. But when it comes to Manhattan distance, it is nothing but you are trying to uh, subtract, may take the absolute value of the two variables, right, x1 and x2. So you get the minimum value, the absolute value, and you sum it up. So how you do that? For example, if you want to reach from point A to point B, you have to come like this, and you have to come to like this. So what is the distance covered from point A to point B? It can be also the Manhattan distance. So similarly, what is Chebyshev distance? I won't spend much time here, but in chess, right, whenever we wanted to go from one place to another place, right, you if you have you suppose your king is on this point, and if your if the if you want to reach to this particular another point, so how what is the minimum distance that you need to go through, that would be called as a Chebyshev distance. Okay, so and Minkowski distance is nothing but you have a formula here, x1 minus y1 to the power of p, and you are summing it up all the distances, and you are taking a equivalent square function for that to define. So uh, these are all the four primary distances, okay, that we generally define or calculate to find the similarity or to find the distance between two different set of records. But coming to, because going forward when I show the example, these will be very important, so that's where I wanted to give heads on before itself. Now, the second thing that you should be knowing or aware is uh, the scaling, right? So this is applicable in the supervised model as well. So what is scaling between two records or two sets of feature is, if you all can see the units of uh, input variables, right? For example, this is a average monthly spend. The unit of this one might be in terms of rupees or any currencies, right? But if you say here number of visits, it is number of visits, it is just a number. Now, how do you calculate the distance between the row number 1 and row number 2? It will whether it is a close or for this particular column, as it has a more value, it will determine, right? So how do you ensure that this all the sets are all these records are being scaled to come to a normal where there is no variance or when you calculate the distance between two records, right? For that, what we generally do, we generally calculate a jet. There is a function called there is a formula called jet score. Calculate is we find the mean of that particular field, and then we subtract the mean from individual values, and then you divide by the standard deviation of that. So that will ensure that all these values, right, whether it's average monthly spend or number of visits or apparel items, all will fall to a common baseline, common thread, from where you can identify or you can know whether it is far or it is less. So that is something also we would be doing it as part of the session or use case, right? So before I proceed, I will just summarize. There are various types of distances. It depends on which cluster or which unsupervised model we would be knowing it, and also we would be interested in knowing we should be doing the scaling of the input variables before we uh, any modeling. So the unsupervised modeling that will help you all to give a perfect defined unsupervised model. Okay. Now, before I proceed, you do any questions on what I discussed till now?
Good morning, sir.
Yeah.
I have a small query. Just now you talked about Z score,
Mm-hmm.
and the expression is your x minus mu y, that is standard deviation. So
Yes. Yes.
is it the standard normal variate? Because the conversion formula remains same for the standard normal variate. Are we going to standardize the data set? by using standard normal
Yeah.
distribution.
Yes, we standardize that for
Yes, sir.
example here I can say when I say xi, right?
Yes, sir.
In example, what is the mean of all this?
Right.
You can simply calculate, right? And then
Right.
you subtract the mean from your value,
Individual observation.
and then you will calculate deviation. So you will apply the same formula for this,
Right, sir.
also for this, also for this, also for this, and you also do this. So in that
Okay.
way, you are standardizing the
Yeah,
entire.
this is a normalization of data. This
Yes,
is a
yes,
normalization of data.
yes,
Okay.
yes.
Thank you so much.
Hmm. Okay, all right. So let me proceed to the next. So now, as we know the scaling, as we know the what are the various distances, we will come to now how we will group the similar objects one after the other, right? So the first, there are two primary methods or methodologies that we generally use in unsupervised model. There are others also, but these are predominantly these two are being used. One is the connectivity based clustering, another one is the centroid based clustering. So I would be giving walking through, or I would be showing a use case for each of these two types. Now, before I proceed to there, I would like to spend some time, some minutes on the real definition of these, and what are all the pros and cons, and what are the um, various concepts that we should know for when we follow each of these clusters, right? So one is the, so when we let me go back to my example again, right? So when we try to find the distance between two records, record 1 and record 2, uh, there are multiple ways of finding the distance between these two. One of the method is you calculate, first of all you do the scaling for default. Now, and after you do the scaling, you calculate how much each record, right, or each set of data features are away from the all the other records. For example, here we have 10 records. So how much the customer A is away from uh, all of these records. Similarly, how B is away from all these records. Similarly, C is away from all the remaining ones. So you can try to calculate the distance for each of these records, and then find, then try to group. For example, here we have a, I have just taken a note of A, B, C, D, E, right? A, B, C, D. Now, A and B suppose are very close to each other. So you group them A and B into one cluster. Then you might have E and C and D into another set of clusters. Then what you will do, you will try to find the distance between E and C and E and D and these two records. Then you will try to group into that based on your distance, whether it is a close or it is far away, right? Similarly, what you need to do is you need to find the distance of each and every line with respect to the other baseline point, and you calculate the distance between all the records, and then you group them accordingly. This is one way of grouping into to finding the similar objects. The other way is, what you do is you find the centroid or the mean. It is not exactly mean. You find a, find a centroid of all these features, and then try to find where you define a centroid. Okay, you define a point, and you find where all these other data features are, whether they are close or away. So if they are close, then you group them into one cluster, and if they're away and if they're close to another point, you group them into the other cluster, right? So that is another way of identifying whether the two objects or two features are similar or distant. So what is the difference of primary difference or set of features in k-means cluster? What we do is definitely it needs only, you have to calculate only if you have k number of centroids, and if you have n number of records, then you will have to calculate only the k into type of distances. But whereas if you see in a connectivity based cluster, or we call that as a hierarchical cluster as well, so you have to calculate these many number of distances to come to a conclusion. So and in a centroid based cluster, what we do is we use only the Euclidean distance, whereas in the k-means cluster you can use any type of the distances. Okay, I want to keep it very simple so that you're all understanding the basic concepts before we go into the use case, right? Till now, any questions you have? I want to go step by step, huh? That's why I'm
Okay.
any specific questions you have till now, please feel free to ask. It may be small, it may be large. Please don't feel shy. Come up and please ask any questions that you have, or any query that you have.
Sir, in elbow method, are you
Hmm.
also still going to find out the distance between
Okay.
the data points?
Okay. Elbow I will cover. I just
Okay.
I will explain about elbow as well.
Okay, sir.
But can you repeat your question? I just wanted to understand
No,
so
I
that I can.
just wanted to know, in elbow method also we are going to find out the inter data distance.
Okay. So see, elbow is not a um, elbow method we generally use in the k-means cluster. Okay. So what we do is in k-means cluster, the first okay, the starting point is we have to define how many types of clusters we generally apply. We generally keep in mind, and then we find the distances for the various other records. So for example, if I choose k as, for example, in this particular example, suppose if I take k only 1, that is, for all these 10 records I will have only one cluster. Okay, ideally speaking, it does not make sense, right? You do clusters to find it is not advisable to have a single cluster for all the set of data, right? You will have at least minimum is 2 and maximum is how many number of records are there, right? So in this example, suppose what is elbow method, but if you take k as a 1, what we will do, all these records will fall into that particular category. If you take, in that case, what will happen is, if you see this is the number of k, and you calculate the what is the variance of the, or distance variance of the particular record. So when you do elbow method, it is nothing but how your graph is when you increase the number of value of k, how your variance, or how your accuracy particularly is getting impacted with respect to your when the model you define or calculate, right? So here what I have done is I have tried to keep k is equal to 0 or 1, 2, 3, 4, 5, 6, like that. So when you define a, when you I will explain in the use case as well, but when you draw the plot, you can see even when the k value of k, that is number of clusters, is increasing, your accuracy is also getting increased, because you will have a clear set of uh, data grouped into the various clusters if you have more number of clusters defined. So if you cannot put all into one cluster, you should not also put all into the number of each record. For example, you have 10 records, you should not put into 10 clusters, right? In that case, it does not make any sense. So you should find a way or a mid path where, for example, it may be 3 or 4 or 5 clusters where you group into all the data points. So how you will know what is the number of clusters that you should um, choose? That will be more visually represented or visually represented when you draw the elbow method curve. If you can see here, when you have cluster K number 2, it is very sharp decrease in it. But when you do from 2 to 3, the rate at which the accuracy or the variance increases or decreases, you can see very small curve here. Again, from 3 to 4, again it has reduced. So you ultimately what you need to do, you need to find a value of K. So from this graph, you can tell that, okay, as there is a very small change from K is equal to 3 to K is equal to 4, so you should try 3 and 4 together, and whatever is giving a better accuracy, you should pick that particular cluster. So that is something, it is a part of k-means cluster only, and you will identify to define or to calculate the k from these values. Hope I answered your question. And
Yes,
this is called elbow method.
yes.
Okay. Right. So what are all the various applications that we use in unsupervised model? There are kind of applications like you can group certain types of images, or you can do customer segmentation, or in a medical, whether all the set of patients have a, whether they are healthy or not healthy based on certain parameters, you can define that also as part of the grouping. And then how the variance will impact the cluster grouping, I have explained in this particular diagram. if your number of if the number of k increases, the variance decreases, right? So that is something you should also be knowing it. All these we will come across in the use case, but I just wanted to keep your minds enlightened so that when I show the use case, you can quickly grab. And the only one more point what I would like to highlight is how do you why we need to do. For example, today there are there are 10 set of records, right? Tomorrow, or there might be new kind of a customers might be enrolled into. For example, let us take a banking, right? So there are 10,000 customers for a particular bank, and tomorrow suppose a new customer arrives in. So your clustering, or your where exactly that new customer should go into which particular group, how do you identify that? So that, for those, as and when the input data set changes, your way of defining or identifying the clustering groups should also change dynamically. So that is something, that is why all the clustering techniques, whether it is a connectivity based or centered based, it is not a one-time operation. You have to keep on running those methods or techniques at regular intervals, so that you get the exact segmentation or exact grouping of the various factors that you would like to do. So that is also very important in unsupervised models.
Sir,
Okay.
uh,
Yeah.
yeah, I have one query, like a very simple one, although.
Mhm.
Can you give one example in which case this hierarchical cluster would work better with respect to K-means cluster? That thing is not clear.
Yeah. So when I explain you the use case, right, I can show that. Um, but to answer your question, right, in which case hierarchical cluster will do better than the k-means cluster. Ideally, most of the times, it is always advisable and preferable to go for the k-means cluster because of its less computational expense, right? And it is very fast to identify. But if you wanted to do, for example, in your in this particular example, right? So in this example, what you have is you have the set of banking customers, and you wanted to identify what are the two sets of groups that you wanted to club together. Now, here you should go record by record, isn't it? How
Yes.
another person is associated with respect to um, another customer, right? How two are associated. You should go with record by records, because the objective of the bank should be to group each of its customer, right? It should not be something like um, how much they are spending, or there are various other parameters, of course. But if the objective of a bank is to group all the various customers to give certain offers or certain discounts or certain interest rates or certain promotions campaign, when they do, they should group all the customers into one particular bucket, and they apply their marketing campaigning methods or whatever to attract those customers or those prospective customers, right? In that case, you should go for your hierarchical connectivity based customers. But if your objective is to find who is the, it is kind of a labeling, right? Which customer does lot of transactions, only which customer does lot of transactions, or which customer does less expense, or who is more serving savings mindset, who is more expensive, wanted to expense more on that, based on certain threshold, right? Your banking is okay, I want to get the customers who are spending more than 10,000 and more. So that 10,000 is what my base reference, that is kind of a one set of a point here. Similarly, you have, suppose I wanted to calculate a set of customers or group who are spending less, for example 5,000 and less. So that is another way of um, another way of grouping the customers. So in that scenario, you go with the k-means clustering concept, right? So uh, you need to think what is the business case for it, right? Accordingly you do. So there is no hard and fast stone written rule that you need to just give me 1 minute. You don't have a hard written rule that you should go for this method or that method. What you should try to do is you uh, try both the methods uh, in with respect to the use case what you have, and then you take a call.
And
I
one
would
more
say,
question.
see, all any machine learning model, right? There is no a thumb rule that you should go with. Even in supervised models also, there is no thumb rule that you should go with only this model in this particular use case. No, it's all driven by the input data. That is the beauty of this machine learning model. If your input data changes, you have to fine tune, you have to scale your models in line with that. So it has to be very dynamic. It is not a static that you should apply only this rule for this approach. There is not, never has been the concept in machine learning primarily.
Sir, one more question.
Mm,
In K-means cluster, pros and cons, it's written curse of dimensions.
mm, mm.
So, if
Yeah, yeah. I knowingly did not highlight it because I was expecting some questions. Good that you have asked. Okay. Uh, Let me ask you, what according to you is curse of dimension? What do you think?
what I think, when as per your figure, I think it is clustered into two groups. If number of clusters are many, in such cases it is curses of dimension. Although I am not sure. I'm just new to this field.
Okay, okay. So, yeah, you are slightly right, but I would define what is the curse of dimensions, right? So, dimensions are nothing but these features. Okay, all these features are nothing but the dimensions. So, when your number of dimensions increase, what happens? Your centroid, you have here centroid, and you are finding the distance of those from a from the various features or dimensions. If your dimension increases, for example, you have a dimension, for example, here we in this case we have five dimensions, but if your dimension increases, what happens is your centroid, right? Isn't it is very little difficult to find out what should be your exact centroid, because when your this particular feature, if it is though it is away from it is false to this particular group, but it is near to your the other group, isn't it? So in that case, though there are 7 out of 10 features are falling into one group for a particular record. For example, if these two, for example, let us see these two, 4 and 4, they are same, but you have other features who are little distance away from each other, right? So in that case, as and when your dimensions of the number of features increases, it becomes little tedious or complex to find what exactly you should be your centered should be. So that is something, but unlike in your hierarchical cluster, it is not dependent on what is the number of dimensions you are, because you are going with record by record here, but here you are going with the group by group, right? So that's why your the curse of dimensions, or it is you can call it as a disadvantage. It becomes little tedious or a little complex when you go for a k-means cluster. So I would try to answer your previous question where you should go with k-means cluster or where you should go with hierarchical cluster on this particular disadvantage. If your dimensions are less, it is advisable to go for k-means cluster. If your dimensions are more, it is advisable to go for hierarchical cluster, provided keeping in mind the accuracy of the feature and also the computational power. So you have to find a balance between these two when you come to any conclusion.
Okay, sir. Thank you.
You're welcome. Okay, any other questions that we should go for? Okay, all right. So let me go to the next one is, see, in supervised models, right? Whether it is a classification problem or a regression problem, as your output is already you have already an output, and your what is your predicted output, whether it is close or different away, that you can find by calculating the variance between those two records. In case of regression or in case of classification also, whether how it is matching or not matching, you can find, because you have been given a data set where there is an output already, actual output is already present. But in cases of unsupervised model, how do you know whether the model that you built or you have come up with, how it is, whether it is highly performing model or is a highly accuracy model, or it is the model that you are looking for? How do you know, right? Because there is no way of any output in this case of data set. So how do you come up with it? So for that, what the famous statisticians and machine learning scientists, what they have come up with is to find for a k-means cluster or a central based cluster, they have come up with a coefficient they call as a Silhouette coefficient, and in hierarchical cluster they try to find what is the cophonetic correlation as an example, right? I would give some um, light on these two coefficients. Okay, now you can see in for example there are three centroids here. Now how do we know whether the centroids of the k-means cluster what I have come up with, whether it is a good model or it is average model or a low perform model, right? You might be having various models for different set of case, right? For example, in this case I have taken k as a 3. Now what I generally do is I find the distance of the particular group. Here I have say ci, so I have the distance between all the various features or the variables from from the centroid. What is the distance of each of these, right? That I store into one place. And then what is the distance of the other points which are not part of this group? What is that distance from this particular centroid? Like that I calculate from all the other clusters as well. Now, and I divide by these two. Okay, if my so I call the in-house distance as the AI, and I call the external distance as the BI, right? With I sum it up all the various distance that I have, and I take an average of that. If for example, if AI is less than BI, I try to find a value of 1 minus AI by BI. Similarly 0, and similarly if it is less than BI is less than AI, then I find the value using this formula. And for these scenarios, what is my Silhouette coefficient? And trust me, all these are already predefined functions are there. I'm for the sake of explaining, I'm telling, if my Silhouette coefficient is more, then that will tell you whether the cluster that you have, whether the model that you have built is a good model or not. Similarly, for hierarchical cluster, what we do is we calculate the actual Euclidean distance between 2 points. So here I have taken the example, right? AB various customers, right? So what is the actual Euclidean distance? And then after we call this as a dendrogram. Okay, this one what I have shown in this example is a dendrogram. Okay, I will show you in the real example use case. So there are two distances. One is the distance between the any various points. In general we call as the Euclidean distance, which I have explained. And then what is the distance between those 2 points in our defined dendrogram? So if these two are close, if your Euclidean distance and the dendrographic distance are close, then you call that as a good hierarchical model. Okay, so you just keep in mind, at the back of your mind, just keep this knowledge in mind, and when we go to use case, we will show you how it is calculated, right? But this is the way we calculate the performance of the models that we build. Any questions till now? Because I will go to the use case.
Excuse me, sir. Sir, excuse me.
Yeah.
The expression which you have written for AI, and that is not visible clearly. 1 by the expression for AI.
So what I will tell you. So you have K is number of clusters.
Right.
Right. So 1 by that number of clusters K minus 1.
Okay.
Okay, you define that one by this one, and you are finding the distance. I will give you when I show you the example, right? You will come to know. But this is something I have explained
Okay.
in another class. I have taken a screenshot. Maybe it is not visible, but I will share you. Like
Sure, sir.
maybe after this class, I can share
Okay, okay, sir.
this one. But this is something we calculate the average of the distances for various
Right, sir.
features. Okay. Similarly, we calculate that. But let me take a note of it. Okay. I will
Okay, sir.
share you the uh, example. 1 minute.
Okay, sir.
Okay. Okay. All right. Okay. Let us go to the use case, right? Okay.
Sir, before that AIBI,
Hmm.
and there was another function SI, I think.
Okay. Let me show that. Which one? This is the silhouette coefficient. How do you calculate that?
Okay, and
Okay.
it depends on this AI and BI.
BI. Yeah.
Okay. So can you wait for a while? I will copy this.
I will send you this slide. Don't worry.
Okay, fine, sir.
I will send this slide. Like last time I have sent it. I will share it with you.
Okay, thank you.
Yeah. Okay. Then let me go to the. Okay. So K means clustering. So for K means clustering, I have taken an example of a technical support use case. Okay, where we have generally there are various problem types. You can all see it here, right? There are various problem types. I hope you have received the data set, right? I think Trupti might have sent it.
Yes, sir. We have
So
received it.
yeah, so here we have the various problem types, right? Now, and for each problem, you will have how many, we call it the tickets or cases, right? How many tickets, for example, temperature control not working, how many tickets or cases have been raised, how many calls have been done, and how much calls are pending for resolution, what is the resolution time, average resolution time for this particular, all these problems, what is the, how many types of recurrence this particular program is occurs, for this problem, what is the number of times you have replaced the equipment, what is the warranty period, and all those uh, features particularly you have it. Now what I wanted to try here is I wanted to group the various types of problems where the distance between each of these records are less, right? So that is what my business problem, or my objective of this particular building this particular model, right? So we have a data set of around 24 types of problems, and we have various uh, relevant features and captured the data for there, right? So my objective is to find a so keep in mind one thing. What is the starting point of k-means cluster? The starting point of k-means cluster is you take some um, number of clusters. You define whether it is a 2 or 3 or 4. How you will define that, how will come to this number of clusters, that is something that I will show in this particular example. Okay. So as I mentioned before, it is always very important to come up to the conclusion using the using the data exploratory data analysis or as well as the visual analysis, right? So in this example, as always, we generally define all the we define our pack we import all the packages, right? The pandas, numpy, these two are pretty common, and you have seaborn for the plotting, statistical tools, jetscore, how do you call it, using the stats package of it. Then you are this is also train test split, you generally do it, and your cluster package for k-means cluster, right? So you have imported all this, and you have imported the data also using the data frame CSV file, right? Then you do just try to find what are the various data types, what is the shape of it, and then what is you do a top 5 records of it, try to see how the data is there, and then now comes the small concept, right? What is, do you know what this particular function does? Any So first of all, you should all learn Python as well, okay? So Python is one of the very hot programming language. You should know the basic syntax or basic programming steps of Python. But any idea, feel free to say what exactly this particular function
I
does.
think selecting a particular column.
Yes, I location, the
Selecting a
selecting,
particular column.
yes, selecting a specific data points from the given data set.
It will
Okay.
locate data point, whether a particular data point will be included in a cluster or not. Location, it will give you the location of a data point.
Okay. Okay, so all of you are wrong. Okay, so my this does what is right. So you have your data set. What is your data set? This is the data set. So remember one thing in Python, your the index starts from 0. Okay, so what I am doing is 0 and 1. Right, this is 0, column number 0, column number 1, 2, 3, 4, 5, 6. So when I am typing here, I am typing here, I am getting all rows. Okay, when I do this particular thing, I'm selecting all the rows here. Then from column number 1 onwards, I'm selecting 1 onwards, here onwards. That's why if you see here, do we have the problem type in this data set? No, right? It is of not importance to you. It may be problem 1, problem 2, problem 3. What is your from here onwards, isn't it? So this tells you the from where you generally start. Am I clear on this one? If you give it here 2, it will start from second column. 0, 1, 2. Am I clear on this one? This is something you should try various permutation combination, but this is something little important.
So by
Now,
giving one, sir, by giving one, first of all, by giving a colon symbol, we are selecting all rows. That's right.
Yes.
And by giving one means we are selecting from column 1 onwards.
1, when I do 1, this one, right? I'm selecting from here onwards.
1 onwards. Okay.
Okay. Here, if I give 1 to 4, okay, what will happen? 1, 2, 3, 4. This.
Right, sir.
Okay.
So this particular function will only for selection of rows and columns.
So this is my data frame. I have defined it here, right?
Right, sir.
Now in that data frame, I am typing a subset of it.
Right, sir.
That I am keeping in this particular data frame. Because I cannot scale these values, right? I can scale only the numericals. My objective is to find the distance between, can I tell what is the distance between power hard and this one? No, right? I can tell the distance between these two from these numeric values. That's why I'm not keeping um, uh, the texts here. I'm just keeping it um, the fields which have the numerics. That's the point. So if I display this one, it will show me all these records from here. It shows like this. Clear? Now let me go to, so once I do that, what I need to do, as I told at the beginning of the session, we need to find the Z score. I mean, how the Z score is calculated, I have given that example in my slide, but that is for your learning point of view. But there is already a function called Z score here, right? You have to just apply to that. So your input data from here to here, and then you are applying the Z score to here. And then you are plotting your scaled data set. You are plotting using your pair plot. So there is, see, when we were when I was learning all these plots and all, it takes around 2 weeks to understand what are the various plots and all. But here you have to just know that what is pair plot, what is violin plot, what is, there are various plots, right? So you should spend some time in learning those, because that is very important for learning any machine learning models. Okay, so here I have done a pair plot. A pair plot is nothing but between two variables, it plots your output for all such combinations. Okay, now any questions still here? Okay, all right, good. So now coming to the visual analysis, right? How do you do the visual analysis? For example, so what you should understand why you are doing the visual analysis. What is the purpose of it, right? The purpose of doing the visual analysis is, first you should know how many clusters you should do. How you will know that? You will know from this particular example, right? For example, here in this particular data set, right? What is this one? There are how many? 1, 2. This can be one group, and from here to here, and it can be another group, and there can be another group of data from here to here. So for this particular example, what is this recurrence frequency? Here in your recurrence frequency, what I am trying to know is, there are various values here, right? 0.012, 0.35. For all such values, for all the things, what is the different various types of peaks that we have it? So from this you can say, okay, there might be 3 peaks of data. Similarly, you can say here also, if you say that it also comes, for example, for this average restoration time, also there are 3 peaks of data, right? So from here you can get a clue. By showing this pair plot, you can get a clue how many, what should be your number of clusters. It may not be the exact, you might get number of, for example, in this particular example, in the replace percentage, there are 5 types of clusters, right? 1, 2, 3, 4. I won't say clusters, 5 types of groups, right? So by here seeing all these visual analysis, what is your objective to find? Your objective is to come to a approximate number of clusters that you should define for your k-means cluster. So in this example, it is coming between 3 and 4 and 5. Okay, any queries till now here feel free to ask. Okay, no issues. It may be a small question, but please ask
No, sir.
because it is very important. Yeah,
Yes.
go ahead.
So there are many plots in first row, second row, what we can see. So in each of the row, we can see one plot like this curve type. So in all cases, it will come like that and we will choose that plot.
Can you repeat your question once again? Let me
Yeah,
understand.
actually what we can see after this pair plot function,
Mm-hmm.
so all possible pairs are being plotted, right?
Yes,
Of
yes,
the features, yeah.
yeah,
So in each row we can see a plot which is fitted by a curve.
yeah.
Only
This
one
one,
curve,
the
yeah,
diagonals one,
the
diagonal one.
diagonals one.
Yeah,
So
yeah.
in all cases, I mean, if there are some other kinds of data sets also, so in such cases also we will get the plot like this. In case of pair plot, they will find the best pairs and plot. Is it like
Yeah.
that?
You will get that, right? So it defines. See, pair plot is one type of plot, right? You can do for others. So see, for example, why you are getting what is this particular graph about? What is the y-axis, x-axis? What is the y-axis, right? So
Yes.
this is nothing but your post warranty percentage and post warranty percentage. You are doing the graph for the same x and y, and you are trying to find what is how it is related
Okay,
or how
okay.
it is plotted. That's why you are getting, then only you will get these curves. Whereas here, these graphs, right, these plots, it is a to tell a relation between, I explained in the previous call, right, in warranty percentage and post warranty percentage, how these two are related. If had it been a supervised model technique or supervised, if you are doing it, then you can, there is this make sense of how one variable has an influence on the other variable, right? But
Yeah, it's like linear regression.
linear regression, right? But that is, you are doing visual analysis of the here, not to identify the linear regression or whatever. You are identifying, your objective is to find the number of clusters. How you will come to know?
Yes.
From these graphs
Okay.
in a single pair plot, right? Or else what you need to, if you want to do, you can do these graphs individually also. You can have some, how many values are there, you can, so many each small graphs you can plot it. But in a single graph, how you can know all these values, then only you can come to a conclusion, right? Whether how many
Yes.
plots or how many clusters you should do. That's why we use the pair plot here.
Thank you.
Yeah. Now, so from this example, right, I am trying to find, see, though it is very apparent for me that my number of clusters should be between 3 to 5, right, from the visual what I have done. But as you all should know how to calculate the elbow method, right? So for that, what I have, we generally use, there are two types of distance functions. Okay, one is c dist, one another is a d dist, right? So in k-means cluster, we calculate c dist. Okay, it is mainly centroid based. I'm just keeping a cluster range between 1 to 10 because my number of features are between 1 to 10. And what is my mean distortion, right? The in my slide I showed you, right? In my slide here, where is that? Yeah, this is the distortion, right? What is the mean distortion that I need to calculate? So that is something I have kept it as a null at the beginning. This is part of the programming language. We just give assign something at the beginning as no records, then we try to append that, right? Then for each value of the clay in the cluster, what is cluster? Cluster range 1 to 10 means it has a range of, it has the values from 1 to 10. Now for each value of the clusters, what is my I'm trying to define a model, then I'm fitting that model, then I'm predicting the model for a scaled data set, and then I'm labeling the minimum distortions, right, mean distortions for this is something a common formula that we generally use. And I'm using, as I said, in k-means cluster we use only the Euclidean distance, and I am trying to find the distortions for each k value, and that I am plotting it here. Okay, for example, k is 1, you have a mean distortion, average distortion is this, and this average distortion is getting reduced as and when you come to the k is 9. So you should not go to either, you should not go for either 9 or 1, you should find something similar. So where is that? For example, you see here when the k is 3, your average distortion is something 1.6, some value, right? And then, but when this k is 2, it was 2, so around 0.4 has been reduced. But from k3 to k4, how much is 1.62? I think it is 1.58 or something, right? There is very small reduction in here. From here 1.4 something to 1.2 here. So this is 1.2. So 0.2 reduction. So your value should, from this graph, you should come to know wherever there is a steep decline, you should not go for it. Where there is a small decline from 3 to 4 or 4 to 5, that is something you should take those values as a and it is an indication. Okay, it is an indication that you should take that value as a number of clusters. So in this
Excuse me,
case,
sir. Sir, can we say that less is the distortion, better is the model? Can we say that?
so less is less in the, I will just add one word,
Yes, sir.
less in change of distortion.
Okay.
See,
Okay.
less distortion will have here. This is
Yes.
the less distortion, but you should not go
And
for 9.
more is the number of cluster, less will be the distortion as the graph
Yes, yes,
as the graph
but it
shows.
should not be that many more. Suppose you should
Yes.
not have 10 records are there and you have 10 clusters,
Clusters, yeah.
then
That
does
should be
not make sense.
optimal
Yeah,
number of clusters should be there.
yeah,
Some
right.
balancing should be there.
Yes,
Okay.
yes, yes.
Sir, sir. Thank you, sir.
Yeah. Then you go for, I mean, this is more programming, but I'm just explaining it here. What I have taken the k as a 3, right? Here I have made it more general. I try to plot that elbow method curve. And then I'm taking k as a 3. Then I'm trying to plot I'm assigning the group. For example, in 3, I have 3 clusters, right? 0, 1, and 2. So when I do that, this particular first record comes to cluster group 0, and then this is 1, this is 2. So what you are seeing it here, you can see from, see these two records, right? These two problems, right? Temperature not working and fan swing not working. Don't you see that, forget this number of cases thing, but you see the other values 1.31, 32, 35, 0.04, 0.02, 0, 0.2, 75, 90, 25, 10. These are very close, isn't it? And that's where you can, it is just a confirmation that the way they have been identified as part of the various groups, they are close to each other. Similarly, you say 12 and 3, I mean, number of cases is kind of, it is not a scaled one, it is actual data. If you see the scale data, you will come to know that. Now, similarly, 2 and 2, same 158 resolution time, though this is a little away, but all other records are more or less same. That's why they are been into cluster 2. Then what you do, I am trying to find the, this is another way of finding the whether the cluster assignment, whatever has happened, is makes sense or not. You can see all these mean values. They are for each group. What is the mean value 0, 1, and 2? This is again another way of exploratory data analysis. You should do that, and then you should do, see, box plot is something I will spend 2 minutes here. In the box plot, what we generally do is, this is the box, right? So in machine learning, you have a concept called outliers, right? There might be number of records who are who fall above the mean or median of that particular. They are very less number of records. Though don't count, fall into the actual set of the more population wherever it is there. It don't fall there. They are completely outliers. For example, someone scoring 100 out of 100, how many number of students score 100 out of 100, or how many number of hardworking students score don't score at all. These two are the extreme cases. They are called as outliers. Similarly, um, those outliers generally been derived from the box plot. You can clearly visually see it, but in this case there are, see here, there might be an outlier here, there might be outlier here. So these are the three types of groups that we have: 0, 1, and 2. In each group, what is the um, uh, data, whatever data is there, how they are being represented, you call that in the box plot, right? Just a visual representation here, right? Similarly, I have done for the for 5. Again, I have done the same group here. I'm trying to show it here, and then there is the box plot of it here. So what you generally do is, if your data set is 10 features, you try to group them as per the clustering technique in k-means cluster in this mode. This is on the k-means cluster. It is very um, all the concepts that you need to know, I have covered in k-means cluster. You should stick to all this, and you should apply various. There are various use cases in the online. You can try for all these data sets using k-means cluster and practice more, right? The more you practice, the better the maturity you will get it in terms of the model building. Any questions with respect to k-means cluster before I start show on the hierarchical cluster? Okay, can I go to the hierarchical cluster?
Yes, sir.
Okay. So as I mentioned in as I shown you the data here, right? What I generally do, I won't spend same methods you apply in hierarchical cluster as well. You are plotting it, you are importing the function, Z-score, you are doing it, you are importing the data, you are scaling. Here in this example, you can see here it is from 2. Why? Because I don't want these two, right? From here onwards I need. So I'm taking that value and applying the Z-score. I'm normalizing or scaling the data. Then I'm plotting the pair plot, right? Here in so one thing I forgot to tell you all is with respect to the connectivity based cluster, right? How do you know whether you can go from taking each of the data set as a point and go towards compressing that into a smaller number of clusters. For example, here I had taken 5 clusters. To starting point is 5, then I have gone to lesser number of clusters, right? Or you can do also this way, right? You can put all the data points into one cluster and then you start chopping off, right? You put the various data points into depending on the distance. You can go from uh, 5 to 3 or 5 to 1 or 1 to 5, right? So you can go this both the ways. So if you go from lesser number, more number of clusters to lesser number, we call that as the agglomeratorian um, method of clustering. The other way is called diversity, reducing the number of clusters on that. So in this particular example, I have followed the agglomeratorian method, where I will just plotting the graph for all these, and I'm trying to find how the data is distributed for each set of data, for each set of pairs, right? From there, I'm again the same routine example here, where you are trying to find the agglomerative clustering technique. This is just my package that you need to import. And from here I have defined number of clusters as a 3, and then my distance is Euclidean. I can do Manhattan or Chebyshev or all other distances. I also can do it, and I can do the linkage is equal to average, right? uh, what is this particular one? When I say linkage is equal to average, uh, what do you mean by this? Any guesses here? Okay, let me explain a small time there. So can I, where I can draw? Okay, let me see. Insert, anything I can do. Okay, shapes. Okay, so there are, for example, there are 2 clusters I am trying to define, right? Okay, now what is this linkage? Call it out. Just let me put my charger. Okay, so what is a linkage here is, um, there are various, how do you calculate the distance between 2 different clusters, right? It may be distance from your centroid to centroid, or peripheral to this peripheral, or from this point to this point, isn't it? So I can say what is the least distance? Least distance is from least, medium, and maximum. If I try to find from the distance between from point A this to point B, then that is called least. From centroid of this one to this one, then that is called medium. And from here to here is, this is not medium, this is called average. I'm just saying. And from here to here, if I find the distance, then they call as a maximum. Now here what I have done is I have tried to use linkage as an average. That means distance between all these features from this point to here, average of the distances. Then I am trying to find fit the model here, and then I am trying to the labeling, label which cluster it falls to, 0, 1, 2, as I have given 3 here. It is assigning all the points to the various clusters. Then I'm trying to group by and finding the mean of those clusters, the main techniques that I apply. Then I am trying to find the covenant relativity index, gendogram, and the linkage, right? So for all these, for example, in this particular example, hierarchical cluster, what I am trying to, what this particular, when I have a number of clusters as a 3, what is this depicting is 0, 2, and 3 are fall to one cluster. 7, 8, 5, 9 fall to another cluster. 1, 4, 6 fall to another cluster. There are 3 things, right? For example, here, as you can see here, 0, 2, and 3. So this, and this, right? A, C, and D. If you can just hide this one, okay? I'm just hiding it. See, all these are falling to one cluster because you see it, more or less they are of the same pattern, isn't it? So all are same 4, 4, 0, and all. So that's why they fall to this particular cluster. Similarly, 7, 8, 3, and 5, and 9, all these are falling to one cluster, and the other one is 1, 4, 6 are also fall to another cluster. So, and it is more hierarchy based, right? That's why you can see it here. Similarly, if I try to find with another complete, this is nothing but the maximum one, okay? Now from here, you also calculate the dendrogram. You have to just follow this thing, and then you keep it. And if you, so all the dendrograms, you come to different set of dendrograms for each hyperparameter you do. If you change that measure of distance, there might be another set of clusters. If there is a measure of distance, also if you change the linking method, also it will differ. So based on that, you come to the various dendrograms. In this example, I have tried to calculate based on the another way of calculation. For example, sample index, right? So for all these, when I try to find and define, I find that all these, if you see the index, for example, here in this case, the similarity index is 0.84, but here it is 0.86. So what I am telling, I would rather go for this particular model because this index is more, 0.86. That way, this is also similar. So you can go for either of these things based on the performance measure that you define or calculate. Any questions till now on this? I will share all these sets. Okay, I think I shared the data. I will share the examples also. But you should keep it to only this level so that the more applications what you have, if you apply all these concepts and learn Python a bit more, I think you should be good on both summary, machine learning, supervised and unsupervised model. Only one thing what I would like to request is you should practice more. You should spend more time on the exploratory data analysis and the visual analysis, and scaling is important. So what are all the key points, right? One is the scaling you should do. You should find the jet score. You should find try to know how to plot these graphs. When you start building it, when you start implementing it, right, there might be a lot of small issues that you might come across with respect to programming side of it. But from a concept point of view, all these what you need to do. Okay. Any questions on this particular use case?
One thing, sir, unless someone does it practically, the things will not be very clear. Concept we understood, but unless until we do it of our own, the coding,
Yeah,
things will be
and it
more
is
clear.
very, yeah, it is not that difficult also. Okay, so
It is,
I mean, it is there are set of things, right? So I have, if I show you, I don't want to show the various others, but if I show few of the examples, okay, uh, there are there are see, to come to there are, for example, if I show decision trend and several techniques, yeah, not this one. Okay, okay, not this. Okay, I'm just telling you, right? See, you should not get more worried on the more Python. It's very, you use small techniques. So if I and you try to use, there are various other ways. For example, in this particular example, I built one capstone project for a pneumonia detection. Okay, for data sets and all, you can build. You can go to the Kaggle site. There are various data sets. So if you see it here, right, there are so many other things that you can learn and do it going forward. But for that to happen, you should practice more on these small and very fundamental concepts and start working on it. If you have any thing, definitely I would say feel free to reach out to me on individually or in a group. Based on availability and all, we can connect sometime and discuss.
Sure, sir. Thank you so much.
Yeah, no problem. Okay, with that, I think I can say if you have any questions, please feel free to ask, or else we can call it a day.
Any queries, you can unmute and go ahead to ask. Okay, so as there is no response from their end, we can wind up the session here. Okay, may I request the participants to switch on their camera so that we can have a snapshot for record.
Sir, mail ID of the expert, can we get?
I'll share it with you, madam. I'll share it in the
Okay,
WhatsApp group.
okay, sir. Okay, sir. Okay, sir.
Shall I also switch on?
Definitely. Please.
Okay. Excuse me because I am in a different room, but yeah.
Okay. Mr. MS Gaikwad, can you change the direction of your system? Gaikwad, sir. It is coming a bit hazy. Means, can you please change the direction of your camera? Yes, yes. Okay. Thank you.
Thank you, sir. Thank you so much.
Thank you, Vikram. Thank you
Thank
once
you.
again for being a part of this FDP, and we look forward for mutual collaboration in future as well in the area of
Sure.
mutual interest.
Yeah,
So,
sure.
on behalf of Department of Production Engineering, VSSUT, on behalf of Hotel, on behalf of all the participants, I once again thank you. Thank you for joining us.
It's my pleasure.
Thank you.
Thank
Thank you.
you. Thank you. Thank you, Trupti. Thank you
Uh,
all.
Participants will start the next session sharp at 11:30. So a few data files are already been shared with you. Also a software which is to be used during the session. That link of that software is also shared. So please download the software, download those data files, and please join sharp by 11:30 because that session is also going to be one hands-on session. Um, it is on biomedical application of ML and AI. So I think it's going to be an interesting one. So please do join 5 to 10 minutes prior in order to avoid any technical issues. Okay, so you can sign out now, or you may stay tuned because it is already 11:10. So we'll start it sharp at 11:30, and for this session, we'll extract the attendance in the beginning. Okay. In every session, we used to extract whenever we see the maximum number of participants. Uh, but for the coming session, we'll extract the attendance at 11:30. So please do join sharp at 11:30. Okay.
Okay, sir. Thank you so
Thank
much.
you. Thank you.
Thank you, sir.
Thank you. Thank you all. Have a great day. Bye.
Thank you, Vikram, sir. Thank you so much.